circuit? Resistance, keyword. Well, we have an equation for that. Imagine that, especially in physics, right? So, R, resistance, EQ, is equal to R1 plus R2 plus R3, and so on, and so on, and so on. So what this tells us is that Req is the equivalent resistance. Req is the equivalent. In other words, it is the sum of all the resistors. So whatever resistors you have in a series circuit, you're going to add them all together. That's what this is telling us. This is telling us we have to add this, and we have to add this, and we have to add this. Okay? Add, add, add. However many there are, we're going to add them all together. That's going to give us our Req. And our Req, which is the equivalent, is the sum of all the resistors. It is the largest resistor in the series. So Req should always be your largest number in the resistors. Largest resistance in the circuit. All right. Along with resistance, you cannot forget about current, because obviously, we have to have current. So how do we calculate current in a series circuit? Current is quite easy, honestly, because when current is going through a series circuit, it's all going to be equal. So current, I, you guys should know that by now, I total is equal to I1, which is equal to I2, which is equal to I3, and so on and so forth. However many i's you want to throw in there, they're all going to be equal. So if one I equals 5, all the i's are going to equal 5. So if I total is 5, 5 is only equal to 5, which is equal to 5, which is equal to 5. Throw any number you want in there. They're all going to be equal. So in a series circuit, current's pretty easy. It's the same in all the circuits. Finally, we have voltage. So how do we calculate the potential difference, otherwise called voltage, in a series circuit? Well, voltage total is going to equal voltage 1 plus voltage 2 plus voltage 3, so on and so forth. So remember that voltage is always going to be different. It's your total. It's going to be added all together. So if voltage is different for each one, if we have, for example, voltage 1 is 1, voltage 2 is 2, and voltage 3 is 3, that means our V total is going to be 1 plus 2 plus 3, which gives us 6. So our voltage total is 6 volts. Our guided practice on your paper. It says, a 4 ohm, 8 ohm, and 12 ohm resistor are connected in a series with a 24 volt battery. Part A, calculate the equivalent resistance. So we have a formula for that. Req is equal to R1 plus R2 plus R3, and it keeps on going. So to find our Req, call this R1, R2, R3. So it'd be 4 plus 8 plus 12, which is going to equal 24. So our equivalent resistance is 24 ohms. All right, part B. So our question says, a resistor of 4 ohms, 8 ohms, and 12 ohms are connected in a series with a 24-volt battery. Calculate the current in this series. Our equation for a current, I is equal to V over R. Now remember, our Req equal 24. So let's figure out what we've got. I is going to equal 24 divided by 24. If you need to put this into a triangle, this was 24, this is 24. So ultimately I equals 1, because 24 divided by 24 is 1. So we just figured out what our I is. The last part says, what is the current in each resistor? Well, this is kind of a tricky question, because what it's asking you is what is the current in each resistor, which is the same. Think about it. Remember, I is equal to I1, which is equal to I2, which is equal to I3. So if our I is equal to 24, then that means that every single I in the series is going to equal 24 amps. There you go.